just to kind of recap, let me do this again because I didn't do it on video. Alright, we're going to put in the function x squared minus x minus 6. Alright, I'm going to put the points. I'm going to put points here, and I'm going to say I want 1, 0, and I want 4, 0, because those are my 2 points, or those are the region. Those are the upper bound and the lower bound for the time that we're actually looking at the velocity. And all I'm doing there is to make sure that I'm going to get the right points in the right spot. Now, if I go to Menu, Analyze Graph, and I go down to Integral, that's going to give me my area under the curve. So if I go to this point, that's my lower bound. If I go up to this point, that's my upper bound. And that's why I put in the 1 and the 4, just to make sure that I have the correct bounds for the time that we're looking at the velocity. And it tells me that we got our negative 4.5. And we already discussed this before I started recording, that this is going to be displacement. This is going to say, if I started at 0 and you closed your eyes and I did all my movement, you open up your eyes, I'm at negative 4.5 now. And so that's what the graph will end up looking like. So the nice thing is, if you have a graph and if it's in the realm of the graphing calculator, you can actually put it in the graphing calculator and you're good to go. Now, let's go back to the actual question. So that was part A. Now, well, actually, if we go back to the graph, where is it going to shift from negative to positive? At 3, at time equals 3. So I know it's negative from 1 to 3 and positive from 3 to 4. So we go back up here, and from A, I know it's negative from 1 to 3. And from 3 to 4, it's positive. So that's going to help us when we talk about distance traveled. Now, if we would talk about displacement, part B, displacement is just going to be the integral from 1 to 4. Now, displacement will equal the integral of the velocity from t1 to t2. So that's what displacement's always going to end up being. Now, so I'm going from 1 to 4 of the velocity, which is t squared minus t minus 6, which is equal to 0. Well, that's not equal to, sorry. That's dt. So this is going to be t cubed over, help me out here, over 3 minus t squared over 2 minus 6t, all evaluated from 1 to 4. Alright, now, so when I put 1 in here, I'm going to get 1/3 minus 1/2 minus 6 minus, I'm going to put a 4 in here. What's 4 cubed? Because, remember, this is going to be f of 4 minus f of 1. Alright, well, whoops. So this is going to be, that's 1/3 minus 1/2 minus 6. You know how it goes. It's early in the morning still. Alright, put 4 in here. 4 cubed. 4 times 4 times 4 is 64 thirds minus 4 squared, which is 16 thirds minus 24. 16 halves. I'm just having a great day. So 16 halves. Good catch. Good catch. Now, I throw this into a calculator. So, if you go to your calculator, you can pull up the scratch pad. This is what the scratch pad is actually there for. Scratch pad is to say, I need to do some quick math. The first one is 64 thirds minus 16 halves minus 24, all that in parentheses, minus 1/3 minus 1/2 minus 6. Now, what did our graph say that this answer should be? Negative 4.5. And did we get what we got? Yep. So it worked out really good for us. Now, if you had to do this by hand, go ahead and do it by hand. It's not that big a deal. These aren't big numbers. So by now, you should be able to do this math by hand. But, are we all okay with that? Alright, so if I go back here, I can say this is equal to negative 4.5. Just like the graphing calculator told us it was going to be. Now, part C, when we're talking about displacement, here's what we would end up doing if we didn't have a graphing calculator. Take your function. V of t is equal to t squared minus t minus 6. Now, I want to set this equal to 0. Right, we're doing distance traveled by hand. Because we already know what the bounds are. We already know that 3 is where it's going to shift from negative to positive. But here's how you do it by hand in order to, in case you don't have a calculator, to tell you. Oops. Well, that was my phone. That's not good. Of course not. Good to go. Alright, so what I would do is I would factor this. Can I factor t squared minus t minus 6? What would I get? T minus 3, t plus 2 is equal to 0. So t minus 3 equals 0, so t is equal to 3. Does that look familiar? Yeah. And then t equals negative 2. So if I'm doing a number line here, negative 2 and positive 3, but what am I really concerned with? What's the region that I really care about? 1 to 4. So if I do this, and this is where this is where I really care, between 1 and 4. So I'm going to pick 1 as a number, because I can use 1 as a test point, because 1 is in this region between negative 2 and 3. So if I pick 1 and I put 1 in here, what's 1 minus 3? That's a negative 2. What's 1 plus 2? 3. So if I multiply these together, what do I get? Yeah, I'm going to multiply them because I got those answers from here. and it ends up being negative, so I know this part's negative. Here I know it's 0. Now, can I use 4 as a test point? Yeah, because 4 is actually on that, it's in this other part of the region. Just because I'm looking at, for the velocity between 1 to 4, that doesn't mean I can't use 4 as a test point. So I'll plug in a 4. 4 minus 3 is 1. 4 plus 2 is 6. That's positive times positive, so it's positive. So this verifies for us that the integral is going to be from 1 to 3 and 3 to 4. So if I take this and I go 1 to 3, it's negative here. What do I want to do to the negative? Multiply it by negative 1. So I'll get t squared minus t minus 6 dt plus, from 3 to 4, do I want the original function? No, don't plug it into a calculator. Do it by hand. Have this for me Monday morning, because we only have 3 minutes to go. That's notes. These are notes. Yes. Yep. Sure did.